Hi, I'm Keon, and in this video I'm going to show you how to solve the separable partial differential equation. So for separable partial differential equation, what we consider is that our function u, which is a multivariable function, is a product of a function of x and a function of y. So f of x times g of y. And as a result, when we, for example, see the left-hand side, this becomes x times, let me write it a little of, this becomes x times the partial derivative with respect to x becomes f prime of x, and then times g of y, and then u is just f of x times g of y, f of x times g of y, and then y is just y, and then times the partial derivative with respect to y, which becomes y times g prime of y, f of x. So what we want to do is that put the x's in one side and put the gy and y's in the other side. So actually what we can do is that we can subtract so both of these from, so we can actually take out the f of x from here and then divide this and also divide it, a g of y from here. So what we get is that we get x times f prime of x and then over f of x, and then this equals, and then we divide gy on both sides, so it becomes actually 1 because we're dividing by f of x times g of y, and then plus the f of x cancel out, plus y times g prime of y over g of y. We're ultimately solving for f of x and g of y and then multiplying them to get u. So as a result, each of these functions, each of these sides are equal to a constant c. And the reason is because when we take kind of a partial derivative of a other variable, it's kind of taking a partial derivative of constant. So what we can actually do is that, I don't have much space, but for example, this is equal to c. And if we actually want to solve this in a way, we can divide x on both sides, and so this becomes, if we differentiate this becomes natural log of f of x. So I'm going to write it as ln, I'm just going to write f for right now, is equal to, and then c over x becomes just c ln of x plus a constant, let's say k. And so f, what f is actually, it is k times e to the c ln of x, but c ln of x is the same as ln of x to the c, and the ln's cancel out, so we get just x to the c. So it's just k times x to the c. And yeah, because the e's and ln cancel out, so this is our function of f, and similarly for our function of y, this is also equal to c. And so when we subtract 1 and then divide by y, what we get is that now we have ln of g is equal to, now we get c minus 1 and then over y. So this becomes c ln y minus ln y plus k. And so this is essentially, or I'm going to change maybe c and k to a different variable. I'm going to change this to maybe b, and also change this to a. And so what we can do is that you can see that g is equal to b times e to the a ln y, a ln y minus ln y. And when we multiply them, ultimately our answer, what it becomes is that the k and b's are multiplied, so becomes a constant. Let's say it becomes, I don't know, become the constant d. Let's say d, and then this becomes d times x to the c, e to the a ln y minus ln y. And that's it. I hope you enjoyed this video. Please subscribe to my channel, and goodbye.